In 2.4, we're going to look at the coordinate plane, and we're really going to focus on using the coordinate plane to represent different geometric figures and their properties. So the specific things that we want to be able to do is find the distance between 2 points on the plane. We want to be able to find the midpoint between 2 points on the plane, and we want to be able to find one endpoint of a segment if you know the other endpoint and its midpoint. So let's get started. A little bit of review in case you have forgotten this. The quadrants. The quadrants in the coordinate plane go 1, 2, 3, 4, and they go in a counterclockwise manner. Okay, so these are our quadrants. Okay, don't forget the x-axis goes horizontally and the y-axis goes vertically. Okay, so let's start by talking about the distance formula. In the coordinate plane, we can represent any point in the coordinate plane using x and y coordinates, right? So it doesn't really matter exactly where this point is, but if I had one point here, and we called that point x1, y1, in other words, this is the x coordinate of the first point and the y coordinate of the first point. And then we had another point somewhere else, maybe right here. Its coordinate we would call x2, y2, because it's the second, the x coordinate of the second point and the y coordinate of the second point. If we had those 2 points, then we say that the distance between them is given by this formula over here on the right. So let's copy this distance formula down. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Really, this is just coming from the Pythagorean theorem. The Pythagorean theorem says, oh, if I want the length of this hypotenuse, it's like visualize this little right triangle right here. x2 minus x1 squared is like saying a squared. y2 minus y1 squared is like saying b squared. I guess that's not a squared down here, that's a. But we know that a squared plus b squared is equal to c squared, right? If I wanted to solve this for c, I would take the square root of both sides. We'd get c is equal to the square root of a squared plus b squared. So you can always draw a right triangle and use the Pythagorean theorem to help you find the distance between 2 points. Or you can plug the coordinates into the distance formula. Okay? So let's look at an example. Let's find the distance between the points 4, 3 and negative 3, 1. Now one thing I really like you to do is when you have your points like this, it's really, really helpful to label them as x1, y1, and then x2, y2. So label them right underneath, and that's going to help you make sure that you plug everything into the correct location into your formula. So the distance is going to equal x2 minus x1 squared. So x2 is negative 3, and then I'm subtracting 4 and squaring it, plus y2 minus y1 squared, so that would be negative 1 is y2, minus 3, which was y1, and then we're squaring that, and then I need to take the square root of all of that. So let's use the correct order of operations. Negative 3 minus 4 is negative 7, and then negative 1 minus 3 is negative 4, and then we're going to square that, and then we're going to take the square root. So negative 7 squared is negative 7 times negative 7, that's positive 49. Negative 4 times negative 4 is positive 16. So we take the square root of that, and so we need to add these two together. 49 and 16, let's see, that's 65. So the distance between those 2 points is the square root of 65. I'm not sure exactly what that is, but I know it's a little bit more than 8 because the square root of 64 is 8. So I don't know, I'm just going to guess maybe about 8.1 or something. That's the actual distance. Actually, that's the approximate distance. The actual distance would be the square root of 65. Okay? And you can use a calculator to approximate these decimal values for the distances. Okay, now let's talk about midpoint. Again, if we're talking about any 2 points in the plane, so let's say we had one point right here, and that point is going to be represented by the coordinate x1, y1, and another point somewhere else, I don't know, maybe it's right here, represented by the coordinate x2, y2. We can draw a segment that connects those 2 points. And if I want to locate the midpoint between those 2 points, I don't know, the point that's exactly in the middle that cuts it into 2 congruent segments, the coordinate of that midpoint will be found by using this formula. So we have the new x-coordinate will be x1 plus x2 over 2. The new y-coordinate will be y1 plus y2 over 2. It's like finding the average of each of the coordinates. So we find the average of the x-coordinates, that gives me halfway between my x's, and we find the average of the y-coordinates, that gives me halfway between my y's. So let's do an example. Let's find the midpoint between points A, 4, 5, and B, negative 2, 3. So again, let's start by writing our coordinates and labeling them. So A was at 4, 5, so we're going to call that x1, y1. And it really doesn't matter if you label them opposite of B. You could have made B x1, y1 and A x2, y2. It doesn't matter. But just label them so you make sure that you plug things into the formula in the right places. Okay, so those are my points. And the midpoint will have these coordinates. x1 plus x2, so that would be 4 plus negative 2 over 2. And then y1 plus y2, so that would be 5 plus negative 3 over 2. And let's simplify that. 4 plus negative 2 is 2. 5 plus negative 3 is also 2 over 2. Don't get freaked out by the fractions. Usually they work out pretty nicely. 2 divided by 2 is 1, and 2 divided by 2 is 1. So that means that my midpoint has a coordinate of 1, 1. Now, we should do a quick little check here. You know my rule is always to draw a picture first, right? I'm drawing my picture last, but let me see if I can't get this a little bit nicer here. Not sure if I have any nice graphs. Let's see here. Here's a nice graph. I'll make it a little bit smaller. Whoopsies. Make my graph a little bit smaller, and I just want you to, do a quick sketch, plot your points, and make sure that the midpoint seems reasonable. So A was at 4, 5. So 4, 5 is about, let's see, over 4, 1, 2, 3, 4, 5. So 4, 5 is about right there. B was at negative 2, negative 3. So over 2, down 1, 2, 3. So that's right there. If we connect those with a segment, does it seem reasonable? And our midpoint would be at the point 1, 1, which is right there. Oh, I think that totally seems reasonable. It looks like it's halfway in between. So just do a quick sketch to make sure you didn't miss any negatives or add anything wrong and that the midpoint looks like it's in the right place. Alright, so the last thing I want to show you how to do is how to find the endpoint of a segment if you know the other endpoint and its midpoint. So let's say segment CD has one endpoint at C, which was at 4, 3, and you know that the midpoint of CD is at negative 1, 2. How can we use that to find the coordinate of point D? Again, let's do the same thing we just did and draw a little sketch. Okay. Make this a bit smaller here. This is quite large. Well, let's do a little sketch. C is at 4, 3. So 4, 1, 2, 3. That's about right here. We don't know where D is, but we do know that the midpoint is at -1, 2. So whatever's going on here, I know that the midpoint is halfway between C and D, right? So this is the midpoint, then D's got to be somewhere along this other side, right? So I should probably label my points. This was C, and it was at 4, 3. This guy was the midpoint, and the midpoint was at -1, 2. And what we're trying to find is the endpoint of D. Okay, so start with your midpoint formula. You know the midpoint is the average of the x-coordinates and the average of the y-coordinates. You also know that your x-coordinate, your new x-coordinate in this case, the x-coordinate of the midpoint, is -1. You know the y-coordinate of the midpoint is +2. You also know x1 and y1, and what you're trying to find is x2 and y2, right? That's what we want. That's our question mark here. So we'll start out with two different equations. We know that -1, the x-coordinate of my midpoint, has to be equal to x1 plus x2 over 2. Oh wait, but we know x1. So we could say that -1, oops, we could say -1 would be equal to 4 plus x2 over 2. And I want to solve for x2. So to do that, start by multiplying both sides by 2 to get rid of this denominator. So 2 times -1 is -2, and that's going to equal 4 plus x2. To get x2 by itself, subtract 4 from both sides, and we get that x2 is equal to -6. Alright, so we're going to save that little piece of information and come back to it in a second. Alright, now we have to find the y-coordinate. We know that the y-coordinate of the midpoint is 2, and that has to equal y1 plus y2 over 2. But we know y1. y1 was 3. So 2 is equal to 3 plus y2 over 2. We do the same thing we did before. We multiply both sides by 2 to get rid of that denominator. 2 times 2 is 4. So we have 4 is equal to 3 plus y2. Subtract 3 from both sides, and we get that y2 is equal to 1. Now let's look at my picture. Does it seem reasonable here that this coordinate is -6 in the x direction and 1 in the y direction? And it does. So that means that the coordinate of the endpoint D is at -6, 1. Okay, so that's it for the notes on distance and midpoint. I want you to go ahead and spend about 10 minutes or so, put in some questions on the left, and I want you to write a 2 to 4 sentence summary for this section. Okay, so do that first, and then you can begin your practice problems.